lecture today. So right now I'm starting for recording. Right, Assalamualaikum and very good morning, everyone. Okay, hopefully you all in a good situation. Right, so we know that we are having a pandemic situations and we are doing on the remote online teaching right now. Okay, so we are about to have a new topic for this one, for this today, week number 4, problem solving using decision logic structure. Okay, so hopefully all the students already download the materials, the notes that I asked you to download and try to read a little bit on this chapter. All right, okay. So this is a topic that we need to cover today. And this is very important for you to understand how you can use decision logic structure for the problem solving before you do the programming technique, which is the technical part. Right. In the previous lecture, we already talked about regarding the problem solving using sequential logic structure. And there is a huge differences between sequential and also decision logic structure in terms of the flowchart, implementation, and also the logic itself, right? So if we reflect again our lecture before, it's a sequential logic structure. There is a very straightforward, what we call the step by step is very straightforward. Okay, so we have an enter a value and then do some calculation and so on. All right, okay. And this chapter we have some additional what we call statements in our case study, which is we have the decision, right? We have the decision that we should have in our program, and we need to know how the logic of the decision structure. Okay, so this is the overview of the lecture, and then we need to cover regarding what is decision logic structure, and then we go on the structure by using the if-else statement. Okay, this one is one of the instructions that we need to look at after that, right? And then we need to look on what is straightforward logic structure. Okay, and then we have a positive logic structure, like this one positive logic structure. We have a negative logic structure, all right? And then we have a logic conversion in terms of how we can change the positive to the negative and the negative to the logic, the positive logic structure. All right. So basically, this is the idea that we need to understand regarding the decision logic structure. And there is one thing that we need to cover as well. So instead of we look on the if-else statement, this one is if-else statement, all right? We have another decision that we call a case, right? So this is one of the decision logic structure that we need to understand also, right? The best thing is this is very important part, and once you understand the if-else statement, then we look on the second part of the decision, which is the case logic structure. So this is what I can say that the example of decision logic structure, okay, in the algorithm. Okay, so uses if or then or else instructions is one of the statements that we should have in the algorithm if we have decision in our program or algorithm or pseudocode. Okay, so if is a condition, if the true. Okay, so meaning that whenever we have a condition and that particular condition is true, so this statement will be executed. Otherwise, it will execute the else statement. All right. So in this case, we have a block of control statement. or another thing is we call it a decision statement that will control our program based on the condition that we have here. All right. So we need to know how we can design our program, okay, and our algorithm that will accept this kind of the condition. If the condition is true, okay, if true, so means that this statement will be executed, right? So otherwise, okay, otherwise we will execute this statement. It's a false instruction, and this design is based on our logic actually. So every programmer, like I said, each of the student have different kind of the logic that, but it will have the same output later on. So that's why we have a positive logic, and then we have another one. We have a negative logic structure, because both of the program will contribute to the same output. Right. So we look on the example, directly on the example here, right? So assume that we are calculating pay and hourly rate and overtime pay over 50 hours at 1.5 times the hourly rate. So meaning that we have two conditions here, right? In order to pay what we call the salary, for example, here. So this one is the first statement, all right? This is the first condition we have. And then we have another condition. If we have the overtime, so we need to pay for the overtime pay, which is over 40 hours. So means that is more than 40 hours, all right? So do something, right? If less than 40, this is the statement that we should do, right? So basically the idea is like that if we have decision in our case study, right? So this is one of the example, a very simple example on how we can create an algorithm, okay, for the previous slide. So we want to pay the salary for the person, right? So if the instruction here, right, and then we have hours is greater than 40, which is this one is the condition, okay, all right, the conditions is greater than 40. 40 is one of the, what we call it, the control here, the variable or anything that refer to the condition, then we will implement this statement. So we have some calculation here, all right? So calculation is one of the operations in the program. Otherwise, or we can say else, okay? So we need to calculate this formula. It's very straightforward. So let's say we have hours, right? So you run the program and then you enter the hours is 39, for example, right? So which statement will be executed? Okay, I will type down here is, write down here is statement number one, statement right, statement number two. All right, so based on the input that we have here, hours is equal to 39, which statement will be executed? Okay, student, can you guess which one will be executed? Is it the first statement or the second statement? Right, it's the second. Because of what? Because the condition here, we should meet this requirement. Hours should is greater than 40, but our input is 39 here, right? Meaning that, is it 39 is greater than 40, right? Is it 39 is greater than 40 based on this condition? Based on this one is false, all right? So it's not doing this statement, but it will go to the second statement. Basically, the idea is like that. Okay, so but if you have hours is equal to, let's say, 41, then it will execute the first statement, right? Okay, so we have some kind of the flowchart here. Okay, a very simple flowchart that represent the flow of the algorithm. Okay, A here is the input value. Okay, so A here is the input value. Let's say 39. Put here 39. Is it 39 is true that will accept this condition? Let's go to this one. And then we do the calculation for the pay rate for this person, right? So B will be the exit, or we can say that the execution that will execute after this statement, right? So there are common use decision logic structure. Okay, there are three here that you should know. The first one is the if statement without the else statement. All right, this one. The second one here is if else statement, meaning that we have at least two conditions. Okay, two conditions we have. The first one here just now we have only one condition. Okay, this one we only have one condition. And the last one here we have a case instruction that you will see that it looks like the if else statement, all right, but it's more manageable if we have more than one, more than 2, 3, 4 options and so on. Okay, so this is example of the if statement that represent the if only statement without the else statement here. As you can see here, we have only one condition. Let's say we have if condition is true, then it will execute. We don't have any otherwise here because we only have one condition here. Certain program, they may have this kind of the problem. Okay, so we need to cater the problem by using only one statement. Okay, one if statement here. Let's say, for example, this one. If student is less than 35, so then the student will have the student count here. So meaning this is some kind of the counting. Okay, the example here is at counting. So we have if the student is less than 35, we do some calculation. Otherwise, it won't do anything for the control statement that we have here or the decision statement that we have. Okay, so say we have a flowchart here. So this is an example of the flowchart for if statements only. So we have only this one, and then if this one is true, it will execute what are the statements that should be true, right? It should be true. So otherwise, we don't have otherwise here because this one is very straightforward because it will execute whatever is will done after the if statement here. All right, so we move on the second type of the if else condition here. So this one is we have a one. Okay, we have condition one, and then we have condition number two here. So the if else statement here, at least we have two conditions. Just like we have this example here, two conditions. Condition number one is one, and then we have condition number two. So each of the condition have the statement inside it. Okay, so this one we call as the block of decision. Okay, right? It's a block of decision that will execute wherever the condition is true. Okay, So this is the flowchart this look like, right? So before this we have only if statement, which is we don't have any other statements in the same decision before. But right now, since we have at least, like I mentioned before, at least two conditions that represent this decision, right? Condition number one, sorry, this condition number one is this one, okay, and condition number two is this one, okay. So based on this condition, which statement will be executed, either this one or this one, right? Okay. So far, is there any question? You can type down your question in the chatting so I can answer your question directly. And then this is one of the example as well. We have a multiple of decision in one statement, right? By using the operator of and here. So we can have this one if we have like a range of marks here. As you can see here, if your mark is greater or equal to 40, and your mark is less or equal to 100, right? Basically, if the maximum max is 100, just to give some idea here. So we have some range that need to be accepted. What are the true condition for this condition, for this condition here? Either this one is a pass or fail. Let's say, for example, here we have the marks here. Let's say marks, my mark is here is 40, right? So since 40 here is under range between 40 and 100, okay, between 40 and 100, so meaning that this condition is true based on this statement here. But if we have the mark is, let's say for example, is 39, okay, let's say for example is 39, so meaning that 39 will falls under the fail status because not meet on this requirement, this condition. So this is one of the examples that we have. If we have in one statement here that we need to have another statements that will what we call combination of one or two condition in one statement. Okay, so the if else statements look like this one, but in terms of the diamond shape here, meaning that is the information in the diamond shape here, you will have two here by using the and statement here. So if marks is greater or equal to 40 and marks is less or 100, and then it's true, right? So let's say you have one of the input here. Let's say marks is equal to 101. Okay, 101. So based on the condition that we have here, let's say for example, if marks, okay, we have marks, we have two conditions here, right? We have two conditions. Marks is greater than 40 and marks is less or equal to 100. But if we have marks here is equal to 100, okay, the first condition here is greater or equal to 40, right? And then your mark here is it 101 is greater or equal to 40? Yes, this one is true. But since we are using the AND operator here, remember that in the chapter number 2, right? If we have AND here, so we need to have true and true in order to get the true condition, right? So, but if we have only at one condition is false, A and true, even we have only one true condition here, so the condition for this one is false, right? It will false under this one, right? For this case, we have 101, so it's not meet the requirement for marks here. 101 is less or equal to 100, and this one will be false statement. So that's why for this one, we have marks of 101 here. It will go directly to the sorry, it will go to the false statement here, this one, right? And then it will print out the fail status, or we can say that it's an error because you are entered the wrong range for this number, right? But to give you some idea, it will falls under this one, even though we have a logic for the math is only maximum is 100, right? Okay. Okay, so this is a differences between the if only statement and if we have if else statement. The flowchart for the if statement is only have one statement here, and you only have one statement. But logically, we must have the false statement here as well, right? But the false statement doesn't have any statements here, right? Doesn't have any statement. Compare with the if else statement. Of course, we have one here, if, and also else here, two. At least two conditions that represent the if else statement. So that's why we have the statement A and also statement B that represent the true and also the false statement. Okay, and the last one here that we have a case logic. Okay, so what is the case logic actually? So the case logic here based on the Sprinkle and Humber. Okay, the case logic structure was made up of numerous set of instruction, right? It made not only limited to, but maybe have greater than 4 instruction or 4 conditions, but only one will be selected. What I mean is here, whenever we have a case study here, we only want to select based on the set of instruction, right? By the user and execute by the computer. Okay, the figure explain generally about the case study structure, like this one, right? It looks different compared to the if-else statement. But since the case logic falls under decision logic structure, so we are using the diamond shape here as well, because we want to accept the condition. Anything that represents the condition will use the diamond shape. So what is happening here actually? So the case logic here will select only one based on the condition. For example, you want to choose a menu from the website. You only choose one menu at the same time actually, right? You cannot select multiple of menu at the same time. So here, let's say option. For example, here, let's say option. Okay, let's say you want to select menu A. Okay, and then you want to select menu B, C, and D, right? Let's say you enter a menu, let's say the option here, you enter the value of A. So then it will go to this one, right? So it will go directly to the A. But if you enter the option like a D, right? Like a D, so the flowchart will go directly to the D option, right? Go directly to the D option. Compared to the if-else statement, right? So compared to the if-else statement, so let's, for example, you have a if-else, right? So we have if-else, we have, and then we have some statement, right? So we have condition here. Go to this one, and then go this one. This one is true, and this one is false. And we have a statement. All right. Sorry for the drawing here. And then we have another statement after the decision here. Let's say, for example, this is the else statement. Okay, very straightforward. And then we have a case here. All right, it's a case. Okay, diamond shape as well. Okay, and then we have multiple of option here. Multiple of option. Okay, let's say this one is A, this one is B, and this one is C, for example. All right, okay. So what is what do you call it, the differences between the if else and sort of case study here, the case condition here. So of course the diagram is look different, but in terms of the implementation, it's also different actually. Okay, so what is happening here, right? If we have some condition here, so the condition of the if else statement here, if okay, if option is equal to, let's say, A, okay, and then we have some statement here, else it will do like this one. Okay, for example, let's say this one is A, and this one is anything is not A. It can be C, D, whatever, and so on, right? So, but if we have here this some our case here, so we have a case. Let's say we have a case of A, right? Case of B, case of C here, right? So the difference here, if we have a if statement will execute the condition one by one. If the condition is true for all the condition, then it will execute all the statement inside of each condition. Okay, but this one, we have option A here. Let's say your option here is A. So it will read one by one. Option is A. Since this one is true, right? It will execute whatever statement is inside the A option here. Otherwise, it will execute for this one. So many times, if else statement will execute one by one, compared to the case here, right? So if your option here is C, it won't go for the A first to get the true condition. No, it's not doing like that. Okay, so this one is for the if else statement. If we see, this one will be false, this one will be false again, and this one will be true. Okay, but the thing is that the case study will directly go to the case of the option. It don't go for the A for the checking. No, it's not true, not true, and then this one is not true. Compare for the if else, it will do one by one. If this one is true, it will execute. But this one is not false. If this one is not false, it will read for the next condition. Okay. So you will see that there are multiple of the what you call the if else statement here. Let's say we have what you call the more than two condition. If let's say this one and then right, and then we have if else again. This one is another condition. This condition again, and then we have if else again. Condition number one, condition 1, 2, 3, then right, and then we end of our if statement 4. We have a 1, 2, 3, then we have a else here 4. This is the end block. This one is the end block. Right, so we have 1, 2, 3, 4 condition by using the if else statement. Yes, we can do like that. Right. So this is the flowchart diagram for case logic structure. Right, very straightforward as well. We have the case of instruction, and then we have end of case instruction. Like I said before, the case condition is not read one by one. Okay, is it this one is true? Is it this one is true? Is this one is true? All right. So it's not doing like that. The case will go directly whatever the condition is true. It's not going one and then we're checking second is it true or not, and then last one is something like that. It's not doing like that. It will go directly whatever the condition is true. For example, this one is true. Okay, and then this will go directly to this one. Okay, right? Okay, for the codes here. Okay, so we can represent the codes for the case here can be character. Okay, can be character string. Okay, character is only one character. Let's say A, right? character string here is multiple of character. Let's say AL, for example, right? You can have a numbers here, 10, or some combination of these of data that a programmer uses to name the option, right? The constant in the case structure. So we can have here like a case A, and then we have a case B, C, whatever, and so on that represent your case. Let's say, for example, menu A, menu B, menu C, and so on, right? Right, okay. So example here, all right, this question here, sir, can we need to write down the then after the else if statement here? Yes, we need to write down the then right after the else statement. Right? Can you see still? Can you still see my slide here? Boleh nampak slide lagi?
Yes, sir.
Boleh, sir.
Boleh ya? All right. So we continue this one. So we have a case of A and a case of B, and each of the case we have a specific what you call the calculation. The A here is we have a rate 0.10, and then for B here 0.05. So we can think about what kind of the decision that we have that represent this problem. Okay. So here we can have some kind of the codes can be entered by the user. Let's say enter the menu. So the user will enter menu A, right? And then it will execute this calculation, right? Okay. So instead of the we have only two condition, we can have multiple of decision in one algorithm or the flowchart that we call this one as the nested decision structure, right? So based on these terms nested here, so we can say that we have another condition inside the conditions, right? So let's say, for example, here we have condition of this one, v equal to c1, right? So if this one is false, there is another condition that we need to check for this one. If this one is false, it will do the checking for V option. If the V option here is false also, right? So it will do this condition as well, right? So and then we have it's not only false only, it will can have true for this one as well. So this is what we call as the multiple of decision, all right? If inside of each statement. Okay, so the thing is something like this one. If V is equal to 61, then, right? So if this one is false, right? Sorry, if this one is true, it will execute for the instruction for this one. So otherwise, it will go like this one. So if one is else, right? It's else. So you will have the another if else statement inside the else here. Say V is equal to C2, right? What are the statement? Then we have a else here as well. And then you will have the if, right, after the else statement. So this is the idea here. Okay, so this is the idea of how we can design our nested decision structure. Okay, so it's look like this one. If this one is false, you will have another condition. Okay, either this condition is true or false, it depends. Right after the second condition, you have another one condition here that represent the true and also the false condition for this one, right? Okay, so we move on the problem solving case that represent a real situation here. For example, an insurance company has four different medical plans. Okay, so four medical plans. The programmer has given each plan a code corresponding to the beginning initial of the company. So if the user choose plan A, right? So if the user for the plan B, sorry, 3 and also K and also E here, right? So these are the options that can be inserted by the insurance company that represent different medical plans, right? So you as a programmer, so you need to think about what are the input is suitable for the program. So based on this one, the input will be character F, B, K, and also E that represent for plan A until plan number 4. Okay, so the company pays for all plan A. The individual has to pay for parts of the others. The medical deduction for plan 2 is 4.65. So these are the condition, or so these are the what we call the operations that will be executed if the plan A, the plan 1 is true. If the plan 2 is true, so this the value is will be executed or it will be used for the company to pay. Any other costs are considered in error, write the algorithm and draw the flow. So meaning that whenever we have enter the value which is not from this option, let's say for example you are enter X value, it will do the errors here. Right? Meaning that it's else statement. It's not belong to the F, B, K or E here. Okay. For example, here we have some kind of this one by using the case decision. So we need to have case instruction, and then we need to end the case. This one, end of case. Okay, both of this one is something like start, something like the start of the case. This is the end of the case, right? So this is the medical code equal to F. Let's say assume that the user enter F, it will do the what do you call medical deduction is 0. We set the medical deduction is 0. Okay, right? So but if the condition for this one is true for B, it will go for this one, go for this one, go for the otherwise it's not belongs under FPK or E here. It will execute, or we can say that this one you want to display a message here. Please enter, let's say for example, please enter correct code. Okay, so you can have some kind of this message to know that the user are entering the wrong code for this program. Okay, right? So this in terms of the flowchart here. This one is very straightforward. I can say this is very straightforward because we have a 1, 2, 3, 4, 5 conditions here that represent FPKE and other than FBK here. Okay, it can be like numbers, or can be like a character, a string, something like that, that represent some errors for this one. But this error we need to handle as well. We can have some kind of the display of message for it. All right, so this is another problem. Okay, so that represent the idea of the decision here. right? So this is an example for it, the algorithm, by using the case of here, the starting of the case, and then we need to end the case as well here, right? So these are the algorithm that you need to have the name of the algorithm here, right? So the name of the algorithm. If you're using case here, so you need to type down the case of. Okay, so this is the what you call it, the variables here that represent the statement. Either we are choosing H, P, C, or S. Otherwise, we need to run for this one. Okay, so this is another example project for the problem number 2. You can try to have different kind of the problem that will represent the if else statement, or we can have the case statement. Okay, right. So this one is just exercise for you. Okay, you can try to go through for the exercise. Right, the sample of the answer is given there. So UMP bookstore sells to wholesale and retail buyer. Okay, so mostly of the questions, I mean, you will get this kind of the what you call informations, right? So you need to extract the information, either this is the decision or something like that. Okay, but this one is very straightforward. The amount is less than 100 and the discount is 2%. Okay, if we have amount of 50, right, so you will deduct 2%, so you will minus 2% from the 50 ringgit, for example, like this one. Okay, but if we have amount of the sales here, let's say 400, right, so you need to deduct 5% from the 400. So the calculation may be something like that, minus, okay, 50 0.02, and then you will get the what you call the discount value for these conditions, right? So this question you need to create a PAC, okay, problem analysis chart, which we already covered in chapter number 2. Okay, chapter number 2. So you need to, sorry, chapter number 3 and 2. So write an algorithm as well, and draw a flowchart. Okay, so you need to have one, it's a PAC. Okay, two, you need to have the algorithm, and three, you have the flowchart. Okay, for example of the result that we have here for PAC is look like this one, right? So we have a given data. Remember that we have 4 elements in a PAC. We have a input. The given data is the input data. Required result is the expected output based on this problem. And processing here, what kind of processing do we have? And then the alternative solution here, right? So mostly we can have a okay, we have a solution for this one. We can use positive logic and also negative logic here, right? Either one. So even you can use the straight through logic for this code. Right, so these are the solution that we have. Okay, we try to look for this one, the input, the given input here. So input here is actually is based on the what you call the amount that represent which statement will be true. Okay, so the wholesale buyer must have release number. Okay, so let's say we have a release number, amount of purchase here, amount of purchase. Okay, and also we have some discount here. Yeah, right. So we have another what we call the given data in the from the problem. Yeah, this one, amount of purchase and number of discount, and then also including 6%. Okay, so this is the given data. You need to extract the information from the case study that represent the data, and then we have the result, the expected result for this one. Okay, so you need to figure out what are the algorithm. Okay, so the algorithm, and also is for the flow chart. All right, okay. Now this one, the exercise number 2 here is very straightforward as well. So develop the algorithm. So algorithm and flow chart for a module that calculates the retirement deduction rate according to the following codes. Okay, the condition is R, P, and also G. Okay, so these are the what we call the condition here. Okay, so you may use the case of statement here, or you may use by using the if, the else statement as well. So for example, you have a we have a case of, okay, and then we have we call it the R here is what is a codes. Okay, let's say for example, codes is R, and so then it's 10%. So let's say codes is P is 8%. All right. Okay. So we move on the condition in decision making here, because this one is very important, and then this one is will reflect either the condition is true or false, right? Okay, remember that we have and, or, and not in previous chapter 2, right? And then we have an expression by using relational operator is greater, this one is less, right? This one is some kind of symbol, this one like an emoji. This one we have a greater or equal, we have a less or equal, this one is equal, this one is not equal, right? So you can have multiple, or we can have a combination of expression that will represent your condition, right? So a variable of the local data type, either we can have true or false statement, and then we can have, like I said before, combination between all these above. Okay, let's say we have a if, okay, if marks is greater or equal to 40, and right, so marks is less or equal to 100, for example. Okay, in order to make this one is true, right, this condition is true, so first condition here must be true, and then the second condition here is must be true. So we have here true and true, so you get true, right? Okay, so these are kind of an example here. If a is less than b, okay, and we must follow the what we call the rules here, right? So a here must have the same data type as b. If you declare here s here is integer, b here also as a integer, means that is have the same data type. You can have different kind of data type here, but both of the conditions here, both of the data type of the condition here must same. If you want to have a character of, let's say a, okay, you also must have a character for the b here, this one, like this one, okay, it's character both of it. You couldn't have integer a and then you have character b, something like this one. Okay, you got the wrong what you call the understanding for uh, the rules here, right? So this one, x and z are numeric data, it's numbers, okay, because we have some operation of plus operation, at least a 1 plus 2 is greater than z. Okay, let's say z here have a number, z here let's say 5, right? We have, is it 3 greater or equal to 5? This one is will be, okay, will be false, right? Okay, so let's say for example, this one is assume that you are calculating pay and hourly rate, right, and overtime pay. So we have a given data, required result, processing here. We try to look on this part, because if else is one of the processing that should be in this section, right, in this part actually processing, because we have two different processing here. The first one is greater, and this one is less than 40 actually, based on the condition that we have here, right? So the first one is this one. If this one is true, it will execute. If this one is true, this one will be executed, right? So if else case can be put in the processing part in the PAC, problem analysis chart, right? So we have another one here, IC. Remember again in our previous lecture, we have this one is what you call control. It's a control, and then we have a sub control here. Sorry for my writing here. This one is sub control, right? For the read, calculate, and also print. Okay? And then we have IPU here. Is looks similar if we have in the PAC. The extension information from the PAC. We have an input. All right, so we have input, two inputs, right? And then we have the processing. To make sure that you understand regarding the what you call the inputs here, try to have separated lines for the inputs. Let's say enter hours and enter rate. You can have like enter hours rate here, right? So but the thing is that since we are entering the data one by one, okay, one by one, so we need to have a step for this kind of the problem here. So enter hours, rate, and then let's say we have another data. Then you have a number three, enter something like that, right? Okay, so once you already enter the tools data here, and then this one is a model reference referring to this one. Okay, if hours is greater than 40, and this one will be calculation. So if you reflect again in our PAC here, it falls under the processing, right? Anything that do the calculation will falls on this one. So that's why in our IPO here, it falls under the calculate module reference. So all the things here, line number 4 until 8 here will falls under calculation. So we have this one calculation, this one a calculation as well. So if hour is greater than 40, this one we call as a processing as well, because we need to do some checking. Okay, print pay is a this print module, and then we need to end it, and this one is the name of our control. Okay, or we can say the control module name. Right. So you already learned about this checking here in order to what you call evaluate or test the algorithm, right? So we have the one algorithm here to calculate pay based on the previous slide, right? So use test checking in order to check either this condition is can be accepted or not. All right. So we can have multiple offset data, set number 1 and 2. They say hours equal to 5, rate here is 30. So result will be 150 based on the what we call based on the condition that we have here. Let's say for example hours is equal to 5. Okay. Let's say 5 is it greater or 40 will be false. And then it will execute the else statement here. This one. So that's why your rate here is 30 multiplied by 5, then you will get 150. Yes, it's 150, but you need to have this checking, which is line by line here, right? So we have doesn't have anything for the line number 1 here because it's represent the name of the algorithm, right? We have an input hours is 5, okay, and then we input the rate here is 30 for second variable. Okay, so input you must have this kind of the symbol here is hours. Okay, question mark is 5, and then this one will we know that this one will represent the input 30, the input as well. All right, okay, so we have condition here. Okay, try to look here. This one is condition. Okay, if this one is condition is true, 5 is greater than 5. Is it 5 greater than 40? Question mark. Then we have is false, right? Is false. So whatever is false, it will do this formula. Okay, that's why you will have what you call another variable here that represent the formula like this one. But if we have like the, let's say this one is 41, and then we have a 30 here, right? This one will be 41. This is 41, and then we have something like this one. And the calculation for line number 7 here is not doing this one. It's not doing for line number 7, but it will execute line number 5 because this one is true. Okay, this one is true. Line number 5. Line number 5, this one. So it will calculate here, okay, according to the formula that we have. Right. Okay, so this is another example that will accept for the true condition for the first condition. Okay, this one is 42. This one is greater than 40. Yes, it's true. Is red, right? This one is true, and then it will execute line number 5 instead of line number 7. Which, if we look again in our what you call line number here, it must be reflect based on the algorithm here. Okay, number 4 here is a condition. That's why we will we will set the condition here. The information from the condition is here, right? This one, line number 4, right? Okay, and so on for this one. You will get the output for this one. Okay, right? So there are 3 types of the decision logic structure. Okay, we have a straight through logic, and this one is we call as a sequential. Okay, one after the another, and there is no else part of the instruction. So means that we only have if true, then we'll execute the statement, right? Without any else statement right after this one. So this one is a very straight, we call it a straight through logic. We have another one here that we call a positive logic. So definition for this one is allows the flow of the processing to continue through the module when the resultant of decision is true, right? When the resultant of a decision is true, whenever it's true, it will execute. Right? Whatever is true, it will execute. And then we have the last one here, we call it negative. Okay, the flow of the processing continues. Okay, the flow of the processing continues through the module when the resultant of decision is false. Right? We have multiple of decision, and then if that one is false, it will read the next statement. Is it? If this one is false, it will read again until the condition is true. Right? So this one we call it the negative and negative one. But I can say that different student have different kind of the logic. They may use the positive logic, or the other student may use the negative logic, but it still gives the correct output. Right? Okay, so we have here the straight through logic. All conditions are tested. Okay, no need for else instruction. Dia tak ada else instruction here. It's only if. Okay, it's only if statement. For example, here that we have if the age is less than 16, then right, without any else statement here, you write down again if age blah 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 blah, then statement. And then you have another one if age is greater or equal to 65, blah blah blah, and so on. So it will check one by one. This is, if this one is true, it will execute. If this one is true, it will execute as well. But if this one also true, it will execute as well. So it will read one by one. Step 1, 2, and 3. That's why you will have the flowchart like this one. Okay, because we having a what you call the structure here is straight through, is straight through. If we look, this one is very straight like this one. Okay, straight. Condition, if condition, if condition. All right. Okay. So can you see here? Without the else statement, right? So this one is what we call the positive logic. Okay, positive logic. Okay, we go through for the example here how we can design our positive logic here, right? Okay, as you can see here, we can see here if age is less than 16, then we have statement, right? Statement number one, statement number two, statement number three. Okay, so the condition that we have here, and then we have another condition, and then we have the last condition here. If this one is false, if this one is false and only this one is true, then it will execute the chess equal to 5, right? Okay, let's say for example here, okay, if we look on this diagram, you will see the true condition is like in the right side of the flow chart. Okay, just to have a FC as a flow chart, it will do like this one, and then we'll go directly to this one. Okay, so this one what we call it a positive logic, right? So and then we have a negative logic here. Just go through for the example straightforward. Okay, let's say for example that we have here, and we have if age is greater or equal to 16. Okay, instead of we are having something like less than 16. Okay, if age is less than 16, then or we have like if age is greater or equal to 16, then right, example you have, if we have an age here is equal to, let's say, 50, which statement will be true? This statement will be true. Okay, this statement will be true and this statement will be false. So that's why we can say this one is a positive logic and this one is a negative logic, because we are having different kind of the expression here. This one by using is less than 16, or we can use is greater or equal to 16. Okay, so that's why we have here if, and then we have a if again. Okay, this one we call as the nested, right? This one is falls under the inner block of the if statement, and this one else here falls under the the outside of the if else statement. We have a multiple. This one we call as a nested as well, nested. Okay, inside the if we have a if else statement. Right. The diagram for the flowchart is look like this one because we are accepting the false statement here at the left side. Okay, right. So if this one is false, and then it we have charged the value of 7 here. Let's say we have age is it is equal to 15, for example. It will execute for this one because this one will be false, right? It's true, and then is it 50? Okay, is greater or less, so it will do for the just one is 10, right? Okay, so since we have a positive and also the negative one, right? So we can have what we call the multiple if else instruction. Okay, we have a combination of the logic type. Okay, combination of logic type here. Either we can have by using the and, or you can using the we call the symbol like this one, greater, in the same instruction, right? So we have a positive and negative logic by using a nested if else statement. Okay, and then we have a straight through. Okay, without the nested here. Okay, without the nested, we only have a if statement. Then you have if again, and so on. Right? So these are the example of the multiple decision if else statement. Or I can say this one is a nested also. It's a nested if else algorithm. So you must have the if, right? And then here. This two is compulsory, right? This one is compulsory as well. But for the then in the else statement, we don't have any then in this one. So just leave it like that, right? Okay. So these are the flowchart for this one, all right? So you will see the what you call the your understanding if you do the sum exercise for it. Okay. And the last one is the logic conversion here. Okay. So sometimes it's necessary to change the logic from positive to negative or vice versa in order to improve the efficiency or readability of the solution. All right. So this one is more on the what you call the efficiency of the program. All right. So either you want to use positive or negative is up to you, but it will reflect to the what you call the improved efficiency for the readability. Right. So you can have an interchange of all then set instruction with the corresponding else set instruction because it will reflect for this one. Okay. So here, let's say we have some kind of the idea here, condition here, right? So we call marks is less than let's say 40. Then we have a marks is greater or equal to 40. But the statement will be different, right? So if you want to accept this one is true, and then you want to accept this one is true as well, mark is less than 40, we call it a fail, right? This one is fail. And this mark is greater than 40 will be pass. Okay, will be pass. Okay, so we have two kind of what do you call it, two kind of condition there, but using different kind of the statement here, right? Is greater or equal. This one is less than 40, right? And then we have let's say marks is what you call is greater equal to 40. Yeah, so this one of will be pass, right? And then we have a mark here. Is it less than 40? Will be fail, right? Okay. So you need to know how you can change into this one into like this one. But the thing is that it will reflect whatever is inside the statements. All right. Yeah. This one will be fail, but this one will be pass because we are using different symbols here, different conditions. Right. So this one example for it. Okay. Instead of we are want to accept severing it for each age, so we have different kind of the logic. All right. For example, here, okay, so we have this one, the symbol here that will reflect for this one, okay, this one, and also this one. But can you see here what do you call the condition for what do you call the statement inside the condition here? It will be like opposite, right? It's like the opposite. This one, okay, instead of 10, 5 here. Try to look here. Okay, try to look here, right? But if you run the program, if you run the algorithm, it's both of this one is right or correct because we are using positive or negative to represent the algorithm, right? Okay, in terms of the logic conversion of the flowchart here, we have a flowchart, right? It looks like we have kind of the what you call the diagram may be different, but the output is same, right? Okay, just by changing the symbol only this one, compare for this one, right? You have this one, right? This symbol, okay, right? You have another example for this one, and then this is another example. You can try to figure out how you can design for this one. Okay, you may read for this one, and then you need to design how we can design the positive and also the negative logic structure. Okay, the best way have you design for the positive one first, right? Positive one. Okay, let's say this one is positive. Okay, this is the fourth positive condition. You need to transform this one into the negative one, right? Let's say this one. The opposite for this condition is greater. Okay, the opposite for this one is 1, so it's greater. It's greater or equal to something like that. This one is less than 2000. So whatever that is less than 2000 here, it's depend on this one. Okay, right? Okay, okay. So how we can design our algorithm or program here is basically based on the case study, right? And how we can read the program more readable, either we can by using the if, or we can by using the case, right? Can either choose only one for it, right? And then which one will require the fewest tests. Let's say we have fewest tests here in terms of we have 4 condition. This one suitable for 1 or 2 condition. Then we can try to use for the if here, right? And then which one is much more easier to maintain is basically the idea either if or the case study, right? So the thing is that how we can use if and also case here, it's reflect what are the solution for the particular problem, right? So basically this is the idea that we already learned regarding the decision logic structure. The introduction part, you already look on what is if else statement. We have a if, and then we have a if else, right? And then we have what we call case. Okay, straight through logic, which is as an only if statement, and then we have a if as well, right? So then we have a positive logic, and then we have a negative logic, and this one is will reflect to the what you call the symbol of the operator, like this one. You change it to something like this one, okay? And then the logic conversion, how you can convert from the positive to the negative logic structure, right? Okay, right. Okay. So far, can you follow my instruction, whatever in the slide here, right? So the recorded session will be given later, and I will try to update in the my YouTube channel. So hopefully you can look again in our slide. Okay. If you have any question regarding this topic number 4, you can try to message me, or you can just type down in the chatting here. So later on we can do some discussion later on. Okay. Okay. So far, is there any question? Setakat ni ada masalah ke tidak? Can you follow my instruction? Can you understand my lecture for today? I know that it will be difficult to understand because some of you have doesn't have any background in the programming, right? So based on my earlier survey, right, there are 70% of you student have a background program. So hopefully you get some the idea how you can design your program. Is not only the codes, but you can know how to create a flowchart algorithm, okay, and also the pseudocode from the problem solving subject, right? Okay, so if you don't have any question, so I will leave it to you earlier for 30 minutes. So the recorded session will be given by today, inshallah. All right. Okay, so that's all for our virtual lecture today, and inshallah see you by this coming lab session for this Friday. Okay, thank you very much and see you again. All right, before I forgot, regarding the attendance, I will give one exercise from the slide here that you need to submit, just like before, in class exercise that you need to submit 1 to 3 days after the lecture. All right, I will share the exercise through the WhatsApp group. All right, okay, thank you very much and see you later.
Thank you, Doctor.
All right, thank you.
Thank you, sir.
Thank you, sir.
Sama-sama.